All right, we are back here again to the recording. This time will be on chapter number 4, which is related to unit root testing actually. As a continuation from the previous chapter number 3, you have realized that a variable, you can a variable, especially the macroeconomic variable, is always exists a trending mechanism. So how to mitigate this issue is that we have to test individually the characteristic of this trending mechanism for a variable itself. That's the basic, or that's the fundamental of the time series econometrics after 1970. In the 1970, again, just recap back of the chapter number 3. In 1970, you have a method called ARIMA, or ARMA without the I, but ARIMA is much more related to what we are talking about here, which is very much related to Box and Jenkins 1970, that soon after there are more discussion on such an issue like Granger and Newbold 1974, and then at the end, before 1980, there's a publication by Dickey and Fuller, the first non-stationarity, or the first unit root testing, formal testing of unit root testing, that to test the characteristic of the variable that exists, Dickey Fuller. So, until today, then there's a lot of extension of it until today, and we have the first generation unit root, the second generation unit root test, and so on and so on and so on. So that's that's the interesting part of it, right? So surely that this one will be, this chapter will discuss on the methods or the testing that is available, especially in EView, right? Okay, so yes, this is the beginning of it. I will be talking a little bit on that part. All right, so some memories, recollection from chapter number 3, as I already mentioned just now. Stationary time series data possess temporarily shock. Over time, the effect will be eliminated as the series revert back to the long run. In contrast, non-stationary will be, if you plot the graph, it will go upwards, downwards, and without any kind of the trend is going up or going down, and that is where it will disturb the regression function, especially the OLS. So that's why we need to understand, that's the reason behind this thing. This non-stationarity is the main reason behind of the nonsense, or what the literature call on the spurious regression. So again, as I mentioned to you, check back your project that you have did, or that you have done, that you have submitted, and you have a grade for it, for your econometric project. Check whether your R square is larger than the Darwin-Watson. Yeah, Darwin-Watson statistic, or lower. All right, let's check that. That'll be interesting to find out. Right, so the idea where the series non-stationary means that there is a no long run mean to which the series return. The variance depends on time and will approach infinity as the time goes to infinity. So that's the basic condition. And initially you have this ACF, PACF, or Box Jenkins to identify the stationary and non-stationary kind of a series, in that sense, from the Collirogram kind of analysis. But then again, these methods is actually been criticized much in the literature, surely, because it's not complete. It's just kind of looking in the Collirogram and looking at the naked eye, rather than have a formal statistics or formal testing to do this analysis, right? So that's why Granger and Newbold, as I told you just now, it goes to move forward to see or to discuss this issue in more detail, and then later on it exists something called unit root test, right? This after that exists, right? 1979 onwards. So why is important to check for stationarity, right? It's important for estimation. At least applying LS or the least square regression or non-stationary variable can give misleading parameter, which is what we call as nonsense or spurious regression. As I told you, um, stationarity important for forecasting. It can tell us what kind of process to build upon our model, what kind of model that is suitable. So checking the individual variable first, as I mentioned also earlier in my earlier videos, that I say that you must understand first the variable, the characteristic of variable, like how we want to move forward. If you want to, let's say you want to get married to your girlfriend or boyfriend, or or you plan to get married to a significant other, which you think you want to spend the rest of your life with them. So you must find out more. You must understand them, you must know the characteristic and everything else before you make that kind of big decision, right? So surely that is the dynamic properties of the variable is important before you estimates and forecast, right? It's alternative again, and suits for the model builders needs, right? Surely that you want to build a model now. That's again why this subject called modeling. You have to understand on that particular individual level first before you move forward. Okay, so this is the basic or the equation side of it. This is a linear stochastic process is said to have a unit root if one is a unit root process characteristic equation tends to be non-stationary. So this basically is just one equation. As you can see here, it's just a simple regression with the one variable, the series by itself, where you have the time factor is there, right? Time factor of this one against until we do not know the lag length, or you do not know the lag length of this variable. All right, and then this is this certainly that if it's remember that when alpha is larger than 1, the series y getting bigger and bigger each period and would have an explosive series non-stationary due to the trend, right? Assuming this is what happening. So when alpha equal to 1, series are said to be random walk non-stationary. That's expected y do not converge to any value, right? So this situation is where one root equal to one of the roots equal 1, where the terms unit root come from. So these terms, why we call unit root test, is because of this understanding. All right, giving such a scenario. But to get you more into this detail, when we do the next video on E-views, I will show to you how this actually happens. What is random walk, what is mean reverting, what is non-stationary, what is stationary, because of that. All right, so moving forward, you have this considered as a AR model. This is certainly an AR model, right? In this process, if the process has a unit root, this is non-stationary trend series TS. Moments of the stochastic process depending on t, depending on time t. Okay, now why this is AR model? Because you see this one is the same as this one, this y, and then you have yt minus 1, and you can yt minus 2, yt minus 3. So it's an AR kind of model. AR model it been exposed to you in econometric, actually, if you still remember that, right? So if you have unit root, yet we said that is integrated of order r, written as something like this. In the case, we need to differentiate or difference it r times to achieve stationary. You need to be stationary before you do the estimation, right? So these are the building blocks of the unit root test, the earlier unit root test, especially the first they call it first generation, where first of all 1976, and then you have Dickey Fuller 1979-81. This is the fundamental papers, fundamental research paper on unit root, especially theoretical papers, where most of the article have to cite them, the citation them, and most of these unit root in second generation, third generation, or even fourth generation, the nonlinear, everything else panel, have to cite them because they are the beginning, or the idea come from them, which certainly coined the idea from Box-Jenkins, and including the argument by Granger and Newbold and all the rest of this literature. And Nelson and Paulser is also one of the important articles that argued that especially in unit root model among the economists, that says that most of the time series in the US economy are non-stationary in level. Right? They have to first differentiate to get the series stationary. All right. Surely that with such a thing exists, as we mentioned in chapter 3, OLS will be invalid. That's why it's called superiors. All right. If you have this, you see AR1 case stationary I1, it can be written as such. Okay. So basically this is what the above, this is actually from the book that I given to you, or the soft copy of it. We test for the order of integration of the series. The numbers of time series need to be differentiated in order to become stationary, and then that's the number of unit root. 1, 2. Normally we go up to I2. I3 is seldom to be happen. I2 is possible, or I0, I1. We know more on that when we do the estimation. Right. So if it's stationary, then or non-stationary in that sense, the shock is permanent. If it's stationary, the shock is temporary, as been mentioned. Why? How this thing applied in the literature, especially in the economic studies, I'll show you a few articles that talks about this. All right. Moving forward. So again, Nelson Paulser, Dickey Fuller, this is the level of or these are the important article that talks about it, right? Especially talks about this kind of stationarity environment, or stationarity evidence. Okay, I think we move forward. Here are testing for unit root and order of integration. Okay, these are the steps that need to be done. And I also the next few slides I've summarized this one figure that summarized the whole thing. You test y can be any variable, can be GDP, GNP, exchange rate, money supply, interest rate, inflation, any variable, especially the macro variable which have time series, to see if it's stationary. If yes, then you conclude this. If no, we move forward. Right? Then take first different. Then test again to see if it's stationary. If yes, we say that it's I1. Right? You see I1 integrated of order 1. Right? If no, we move forward. Then we see that whether second different. We stop until the variable is stationary. Right? Then we stop. Okay, that's the process. Easy, straightforward. So here it's interesting. I'll go back with this figure when we do the estimation of E-views, right? Because this figure is very important. For time being, I think you might get confused, but then again, I'll try my best. You have 3 equations here. This is one. This is the second equation. This is the third equation. The first equation here actually is the most general equation. Okay. Here let me start from the one down here. Here is without constant and trend. Without constant and trend. This equation. You see this equation carefully. Without constant and trend. This equation is with constant. This equation with constant and the trend, right? Which is actually available in most of the unit root testing, especially for ADF, right? Especially for ADF. You have Dickey-Fuller, DF, and ADF augmented Dickey-Fuller, 1981. That's the version of it, ADF, which is available in E-views. Right, so these are the important article, the ADF, right? The and so on and so on and so on. This is like a family tree. This is like a family tree of unit root. So you have the conventional, or I would easily call that the first generation. First generation is from here to here, and then we move forward the more latest generation. Here is the structural break. This one is another school of thoughts, another interesting part. Right, the unit root 1, 2, 3, 4, 5, 6, the ADF, the Philip Perron, in short they call it PP test, P and P. DFGLS is Dickey Fuller generalized least square, 1996. KPSS is Kowalski, Phillips, Smith, and Shin, if I'm not mistaken. Yeah, they are the names. KPSS 1992, and then you have ERS, Elliott, Rotterberg, and Shin, if I'm not mistaken, 1996 too. And the NP is Ang Perron 2001. This is all available in eViews. Can test all, can use all the method. Here on this side of the coin, this side of the family tree, the family tree of unit root, you have the structural break, and then you have single break and multiple break. What the heck is that single break and multiple break? I give you a simple example. In a series, if you plot a series, if you plot a series like this, let me draw some graph. You plot a series, it goes up like this, suddenly drop and then goes up, oh, like this. So here, in this sense, this part, this section, you might have a break because the trend, although is moving upwards or downwards, but there's a break, there's a break lah. It's taking a break, stop for a while, and then suddenly it jump up the series or jump down, big. So this conventional one could not detect this conventional could not detect this kind of phenomenon. So that's why we need a unit root test. The unit root test which can include the structural break. It's like, for example, you have if you use iPhone, Apple, you have iOS 11, iOS 12, the upgraded version. This is the upgraded version, the structural break, with existence of another version, another better version to detect such a break. This is single. Single means one structural break, one. Multiple means that it can detect two or more. Wow, that's the interesting part. The single one is available, I think, this Perron here is available in eViews. Zivot Andrew here for endogenous is available in eViews also. And Perron 97, if I'm not mistaken, also available in eViews. The multiple one, as I understand, I might be wrong here with maybe eView 12. All of these are not available in eViews yet. Exogenous, endogenous break means that exogenous is determined outside the model. Endogenous determined inside the model. Outside the model in this sense means that if you use endogenous break, it means that you determine yourself. You determine the break. Let's say 1997, 2008, 2000, and 2020. 2020 is an interesting year for many years to come after this, where you have a significant change in the whole, how we see the world and how everything changed like this. And that impact a lot of other sectors, every sectors actually, and that is a structural break, a significant structural break. So exogenous means that you determine 2020 have break, right? This one, on the other side, endogenous means that you let the statistical program run for you, estimate for you, and let the data tell you the story. Let the data tell you there's a break in 1997, there's a break in 2008, there's also a break in 2020. That's the two different. Okay, from here onwards, from these slides, onwards, yeah, from these particular slides onwards, especially, let me check my slides. From this particular slide onwards, this is all about the methodology that is available in eView. So I do not want to go in detail one by one, but rather I will show you when we do the estimation in the next video. So this is ADF. You can read through these slides. This is ADF. This is DFGLS. This is the PP test, the Philip Ampere 1988, and then you have the KPSS test, and then you have this ERS or Stock, not Shin, Elliott Rothenberg and Stock, and you have the Ampere 2001. So all this is available in eViews. Yes, there's always a limitation in the unit root test, surely, or any of the test statistical. Yeah, we are talking about statistics here. All right, so these are the right. While running unit root test, the null normally the variable has unit. The low power unit root test means that we often unable to reject or wrongly concluded the variable has a unit root. So there's surely a limitation for the unit root testing also, which is available, which is cited here, Mahadeva and Robinson 2004. You can read the article. Right. Time series representation is necessarily a reduced form model of the series. Consistent but not the same. We lose some information from the process, and then so in this case we take unit root. So yeah, surely it says unit root have a limitation. So what's the point of studying it? And types of analysis, type of object, depending on the objective of what you have to study. Every methodology evolved for the past 30 years and very own advantage and limitation. Knowing what you apply, analysis. So that's why modeling part here is important. Understanding the variable and then choose the best methodology. Right? Yeah, this is a good advice there. Never get attached with what you learn in the class, especially. Yes, means that don't listen to me. Or don't listen to anyone who teach you econometrics. It's so wide. Sometimes you know a little bit. The things are dynamically change for so many years. But for time being, this is the methodology that you should understand and do, especially for your FYP and for this project for the class. Right? This is the references. You can have a look. Right? Surely there's a lot of references that you can read through. Right? Okay, I think I'll stop here for this moment. Thank you and adios.